Hello everyone. Today we'll have our Somerset Math Circle Club, the second lecture. Today is October 27th. So first, today we'll mainly talk about exponents, geometry, and patterns. We'll start with part 1, exponents related properties. First property we have the square of negation. Negative a bracket square, the square acts on negative a equals to a square. The second property is squares are non-negative. Squares of real numbers are non-negative. The third property, negative a square is not equal to negative a bracket square. So negative a bracket square is a squared. So we can see that in practice problem 1, it asks you to prove why negative a bracket square equals to a square. This square acts on the whole number, negative a, not just a. So last curriculum that we have talked about this, a, say you have a number a, then you have a negation of a, which is negative a. So negative a square by definition is negative a multiply negative a. So this we can see as a double negation. So get back to the original number, which is a square. Or you can look at this as negative a equals to minus 1 multiply a. Okay, and negative a square by definition is this. So that is negative 1 multiply a multiply negative 1 multiply a. Negative 1 multiply negative 1, that is 1. Then you have a square. Part B, can you explain why square are non-negative? Students can use, for example, if you have a number that is positive, say that number is x greater than 0. So then x squared equals to x multiply x, which is going to be greater than 0. When x equal to 0, 0 squared equals to 0 multiply 0, that is 0. When x is less than 0, you have x squared, then you have x multiply x, and that can be written as a negation of a positive number. And this can be written as that too. So both are double negation. So it would come out as x squared, as the minus x squared. You get rid of these two negative signs. This is a positive number. Positive number squared is still going to be greater than 0. Property number 4, square of product. A multiply b bracket square equals to a to the square multiply b to the square. So students need to be very careful about where the bracket is. So a, b, bracket square, this square acts on both numbers. So you need to have, by definition, this is ab multiply ab. Therefore, you have two a's multiplying together. You have two b's multiplying together. Always, if you're not sure, always carry this out. Square acts on which term, then you write it out. If we have a b square, then that's a different thing, because this square acts only on b. So you have a multiply b multiply b. This is the definition for b square. So when this gets complicated, the best way is to write it out. Square of reciprocal, 1 over a square equals to 1 over a square. Power of product. Power of product is a generalization of property number 4. Property number 4, we have the power, the exponent equal to 2. Now n can be any number. Remember, when these two multiply together and the exponents acting on both, you have to have a to the nth power, b to the nth power as well. Basically, ab n to the power of n is ab multiply ab multiply ab, and this is n times. Okay. Property number 7. power of reciprocal. This is a generalization of property number 5. 8, power of quotient. If b is non-zero, a divided by b to the power of n is a to the n divided by b to the n. Basically, this one is a over b to the n equals to what? So we have a over b multiply a over b multiply how many times? A to the b n times, okay? Then you collect all the a terms, that's a to the power of n. You collect all the b terms, that's b to the n. Therefore, you have this. Property number 9, power of negation. If n is odd, negative a to the n equals to negative n to the power a to the power of n. If n is even, you can see that the minus 1 to the power of n. If n is even, that's a positive sign because we can look at it as pairs of double negation. If n is odd, then when you do all the double negations, there's always one negative sign remains. So therefore, that's a negative sign here. Property number 10, product of powers with the same base. So a to the power of m multiply a to the power of n. So this, again, if we want to prove this, first term, a to the m, is a multiply how many times? M times. Okay, m. And then the second term is multiply a, how many times? N times. So this is how many a's multiplying together.